Good morning, everyone. My name is Francisco Huertas, and I will be one of the presenters from today's webinar. Let me share my screen first. Yeah. Okay, first, welcome everyone. Can you hear me properly?
Yes, we can.
Yes.
Okay, thank you. So welcome everyone for today's webinar that is focused on the validation of the integrated risk management and decision support system, which are being developed in the BIORIMA project. So please keep your mics turned off because there could be some problems with the audio. And this webinar is going to be recorded because we will be able to use it with other people that will attend in remote. So my name is Francisco Huertas, and I've been working together with my colleague Inmaculada Colmenar in this validation webinar, and Alex Zabeo from Green Decision will make today an example of the usage of the decision support system. During this webinar, we will be using the BEVOX system in order to make you some questions. So you can go to your cell phone or tablet or your computer and go to the link that is on the screen. And using this meeting ID, you will be able to see some questions that we will be launching during the presentation. Of course, those answers will be totally anonymous. So what is the BIORIMA project? This project is a European funded project, a Horizon 2020 project, in which 41 partners from 16 different countries, including China and Japan, are working together. It is based in 4 different pillars: the characterization of different materials that we will see in a few minutes, then the evaluation of the hazard and exposure of those materials in order to evaluate the risk, and finally to develop an integrated risk management framework. So this is the main objective of the project, to develop an integrated risk management framework for this kind of nanobiomaterials. These nanomaterials are molecular materials composed partially or totally with biological molecules, which results in different structures that have at least one nanoscale dimension. This can you please turn off your microphones? I'm hearing some noises. Okay, thank you very much. These nanobiomaterials can be used in either medical devices or advanced medicinal or therapeutic products. And we are expecting a very high impact because we will be able to enable industries and regulators to use different tools for high quality data and informed decision making. Here you can see the diagram for the integrated risk management framework. In here, as you see, it is based on the different nanobiomaterials, which can be included in either medical devices or advanced therapeutic medicinal products. We are evaluating all the different stages of the life cycle of these nanomaterials, from synthesis until the end of life. And this, with these specific materials, it can be led to 2 different exposure routes. First, during the use phase, it could happen an intentional exposure because we wanted to have this exposure. So after gathering the existing information on and identifying the data gaps that we have, we can make a balance between the risk and the benefit about this the usage of these different products, and we can propose using this framework different risk control and risk management measures. Then for all the different stages of the life cycle, we can have an unintentional exposure that could happen in different processes, and it could lead to an exposure either to occupational to the occupational world for different workers, and also to the environment. So here, performing a risk assessment after making a physicochemical characterization, we can evaluate either the exposure and the hazard of the usage of this nanobiomaterial, and evaluate the risk and also offer different risk prevention, control, and monitoring measures. More concretely, this risk management framework and of course the decision support system is based in both occupational risk assessment and environmental risk assessment, and both contains an exposure module and a hazard module in order to evaluate the risk. So we will go through the different modules, and Alex, after my presentation, Alex will give us an example. So for the occupational risk assessment, as I told you before, we have included here all the different life cycle stages, from synthesis to end of life, going through the product manufacturing and use. And here we have included 3 different routes of exposure, which are inhalation, ingestion, and dermal contact. For those routes of exposure, we can estimate the exposure with experimental data, if we have it, or we can launch different models to calculate it. In this case, for the exposure in an occupational point of view, we have these 2 models. First, an inhalation model, which has been developed inside the BIORIMA project, which basically can model the near field and the far field from to estimate the concentration of these particles in both places. This is based on basically on the physicochemical parameters of the nanomaterial and the characteristics of the activity performed and the room conditions. And then we have the I-EAT model for the inadvertent ingestion, which is based on 4 compartments, included 9 different processes of mass transport, and it includes a database with more than 500 empirically measured transfer efficiencies. Those here we have the literature, so, and it's also at the end of the presentation, so you will be able to consult all the different models. For the hazard assessment, in the occupational risk assessment, we also included all the different life stages. And here we have 3 different, again, the same 3 different routes of exposure, the inhalation, ingestion, and dermal contact. And here we have 2 different models. The first model, based on toxicological studies, we are able to transform those response data to benchmark dose. And then with the second model, we will be able to transform this benchmark dose to a DNL, okay? Then if we move to the environmental risk assessment module, of course, we again include all the different life cycle stages. And in the case of exposure, we are including 4 different environmental compartments, which are soil, sediment, air, and water. We can use, we will be able to use 2 different models in order to estimate the concentration in those different compartments. Both models has been developed within BIORIMA project, and the first one, the probabilistic material flow analysis, is able to predict the emission and the environmental release concentration of these nanomaterials along the life cycle. It is published, so you will be able to consult if you want. And then with this release estimation, with an environmental fate model, we can see the location of the different nanobiomaterials in the different compartments in time. So we will be able to see if from here to the next 10 years, for example, where are all these nanobiomaterials, if they are moving to the air until the water, or if different transportation movements. Finally, to see the effects of these nanobiomaterials, we are also including the different life cycle stages and all these environmental compartments. And we have this species sensitivity distribution model in order to derive the PINEX based on ecotoxicity tests on different, we can include different species. So based on that, the risk management framework, the different partners from the project is developing a kind of decision support system, which is a web-based tool, a very user-friendly tool in order to guide the different users to comply with the existing regulation and find the best practical solutions for testing and handling the nanobiomaterials. Here you will see the different references of the models that we've seen, and now I will start with the questions. So let me share this. First of all, some introductory questions just to see where are you coming from and what do you know about biomaterials and so on. So if you can choose here your industrial sector, if you come from the medical healthcare or pharmaceuticals, life sciences, cosmetics, chemicals. Okay, it seems that today we don't have any attendant from the medical healthcare or pharmaceuticals. Okay. Okay, thank you very much. So do you know what is a nanomaterial? Okay, everyone is pretty clear that everyone knows what is a nanomaterial, which is very good. Are you working with any of these, either nanobiomaterials, which are the materials we are working with in the BIORIMA project, or nanomaterials, or other hazardous particles such as chemicals? Okay, thank you very much. What kind of material, product, or service do you manufacture, provide, or use? Here you can write the name of the material you're using, such as, I don't know, graphene, or if you are working with metal oxides or silica. Yeah. Mm-hmm. You can write more than one answer if you want. That's good. We can see that some of you are working with organic materials and others for inorganic and oxides. Okay, very interesting. Then, are you aware of the health hazards of the substances that you work with, or you are not aware? Okay, most of you are aware of the health hazard problem that could happen with the substances. And then, are you aware of the environmental effects of the substances that you work with? Mm-hmm. Okay, thank you very much. So this is the last question for this introductory part. So now I will give the floor to Alex, which will give us an example of the web platform, the DSS.
Okay, thank you, Francisco. I hope you can hear me well. I guess so. Okay. So welcome everyone and good morning. I will now share my screen and start presenting the DSS. Oh, I guess Francisco has to stop sharing.
Yeah, now, sorry, I was
No.
find the button.
Okay, here we are. So this that you're seeing now is the landing page of the BIORIMA DSS that you can reach by navigating to the sans.gd website. As you can see, this web application has is divided into parts, and we will see afterwards. And today we will only work in the BIORIMA red part. So I already have a user, so I can log in. But of course, you can also do self-sign up. So if you like the tool, you can just create your credentials and then start playing with it. And obviously, if you forgot your password, you can recover. So let's log in. So once I enter the tool, the first thing is I have to choose which kind of assessments I want to perform. You can see on the left side, we have nanomaterials used in consumer products, and on the right side, nanobiomaterials used in medical devices and ATMPs. So today we will look at this BIORIMA related part. Again, in BIORIMA, we have two parts, two types of assessments. One is related to IATAs, and the other one is the risk assessment and risk control part. The IATAs part is still under development, and today we will focus only on the risk assessment and risk control. So This is the first screen of where we have proper inputs to give. And we can see that we are landed in the project selection page. So in this page, you have a list of all your projects. And the project is defined as something like a folder where you collect all the assessment information related to some kind of product which contains nanoparticles. In some cases, the product can be the nanoparticles themselves, if you're a producer of the nanoparticles. Inside the project, you will collect all the information related to this specific project. So as you can see, the name of the project should explain the content. You can also see here that I already have 2 projects in my list, and that both were created by my colleague Virginia. And this is because you can also share projects with your colleagues, and we will look forward into it next. So Virginia created this project just for today, for the webinar, for example. As you can see, we have some buttons here. We can duplicate projects. If you have something very similar, you can duplicate it and then modify. Obviously, you can delete the project and then you can enter the details of the project, but we will see this at the end. So let's look at what can we find in a project. Once I enter the project, I get in the assessment context section. So here we have a list of assessment contexts. So an assessment context is something a bit broader than an exposure scenario. So it includes exposure scenarios, so ways that, for example, workers perform the work, but it's broader in the sense that it's different ways you can obtain the same product. So you can produce your nanoparticle or your product containing nanoparticle in different ways, meaning that you can perform different actions or different jobs. You can also use different nanoparticles or apply different risk management measures. So every time you have something different in the production that you want to compare, you can create an assessment context and then compare them according to human health and environmental risk assessment in order to understand which is the best one in this regard. And this is the main aim of the tool, the ability to assess and compare different contexts. But let's go back to the list of projects and try to create an empty new project so that you can see what happens in this case. So I give the project a name, for example, sunscreen cream. I can also add an image, for example, like this, and create my new project. So as you can see now, we have a new project, and this one is created by me about the sunscreen. So what happens when I enter in the assessment context part? The system is telling me that I must create an assessment context. But first, I also have to fill in to decide what I want to assess. And this is done through the assessment tree. That's what we will see now. So in the assessment tree, we have the occupational and the environmental branches. Each of those is then built on different life cycle stages. So we have a synthesis, product manufacturing, use, end of life. And inside each life cycle stage, we have different routes for the occupational setting and different matrices for the environmental setting. So for this example, we are probably manufacturing the sunscreen. And we are interested, for example, in evaluating the inhalation and the inadvertent oral parts. And as far as the environmental, we would take a look at soil and water. So I keep this simple for the example, but you can select as many as you wish in order to be complete. Once I'm done with the tree, I create my first assessment context. So this might be something like feeling. So the more detailed I am in the name of the context, the easier it will be to differentiate between the contexts. You can see that we can also supply more information about the context. For example, the nanomaterial characteristics, like something like this. So this is just textual information. It's not used by the system as it's still not necessary to run the models. So the different inputs of the models only rarely require characteristics, but we are planning on adding also that. So we can establish different characteristics for the product, the process, and the operational conditions, and this would help again in differentiating the different contexts. So now the system is creating all the tables necessary for this context, and we have our first context. So we can always go back to the tree and modify it as we wish, and the system will update. So once we enter in the context, we can see we have two sections. One is related to risk assessment, and the other one is related to risk control. The same sections you can find in the left side menu. So let's start with the risk assessment part. We can see here that the risk assessment is divided in environmental and occupational. And both are divided in the exposure and effect, or exposure and hazard. So once you specify these two parts, you get the result about the risk that you can check in the results page. So let's see what's in the occupational exposure page. What we can find here is that we have one row for every branch of the assessment tree that we enabled previously. So we are in the product manufacturing life cycle stage, and we enable only the inhalation and inadvertent oral routes. That's why we have only these two rows. On the right, you can see the part where we can establish the value for this, for the inhalation of the product manufacturing. We have some buttons here. So we can just state that there is a negligible exposure, meaning that we are sure there is no exposure and we don't want to input any number. So we can just click here, and you see that this row became white, meaning that the value has been inserted. You can see that it was inserted manually. This is as opposed to calculated by a model that we see now. So another thing we can do is we can change and say that we have a deterministic exposure. So in this case, I can input a single number that I already know related to the exposure, or we can deal with probabilistic exposure. And again, if I already know the value, I can just input here, and we can input in different ways. So I can say it is something between 0.5 and 1. And this is a lower and upper confidence limit. You can see that the tool already computed the probability distribution for this. Or I can transform this in mean and standard deviation if I have these values instead. But what happens if I don't have the values? I might want to calculate them, and for this I can use a model that is embedded in the DSS. So by going to this green icon, you can see we have two models, one for exposure derivation of the oral route and one for the derivation of the inhalation. So let's see what happens when we enter here. So this is similar for all of the models. We have a page with all the inputs required by the model. So on the left side, we have the definition of all the inputs. And as you can see, we already provide default values for everything. These values are the most general ones. So you might be happy with some of them remaining as default, but you should definitely change the ones that are different in your environment. So once I input all of this, I can run my model. So we see many things here. The job has started and the exposure has been derived. We have an immediate result here, reporting near field and far field concentrations. And I also have this new badge here saying that I have one new model run. So in this page, I have a list of all the models that I ran in the past with the final condition. So the model run, I can go back and the system selected the exposure from the model result, and you can see that now the data is computed by a model. Same thing I can do for the inadvertent oral. So I click and go inside this model. Again, you have the definitions, and you can see that for specific parts that might require more detail, you can just over your mouse and see the description. Again, we have a lot of information here. I just decreased the number of simulations to make it faster. And you can see that for every model, you have the reference in this bottom part, so that if you need more information, you can always go and give a look. Now I can also run this other model, and we can see, as this is a probabilistic model, we get again an instant result, but with a probabilistic interface, and we have a lower and upper bounds of the exposure. So at this point, we have both. So let's move to the hazard part. The interface is quite similar, but not exactly the same. Anyways, we have the two rows related to inhalation and inadvertent oral. In case of exposure, it's the same model that we can run. And also in this case, we can say we have a harmless or harmful effect, meaning that we don't have to input numbers. We just say it is sure that it's harmful or not. We can have a deterministic value, or we can go for the probabilistic, but more interestingly, we can run the model. In this case, we are not directly in the model input page, because first we need to set up biomarkers. This because for the same route, in this case inhalation, we can have different biomarkers expressing the dose response for this thing. So let's suppose I decide for repeated dose toxicity, and I can say something like this. So I create this biomarker, but then I can have more than one. So I can and do something like this. Obviously, you can have as many as you wish. So now we have two biomarkers representing for this route. We can select each of those. We can directly input the data, or we can run the model. So let's see what's in the model. So we don't have any point of departure, so we have to estimate it. And this is the inputs required. These are very limited inputs. And then what's required are those response data. You can input these manually or just upload a specific Excel file. Let's see how it works. So I can download a template of the file that I can fill in and then upload. So now that I uploaded the contents, you can see they are in the table, and the run button is enabled. So I can run this model too. This will calculate the BMD. So what we got now is the benchmark dose evaluated again in a probabilistic way. And now I can move to the next section to move from benchmark dose to derived no effect level. So in this part, we will apply assessment factors. We have, again, all the inputs here. We have assessment factors here, and we can also add other assessment factor extrapolation aspects if we want to. Also, here we have the part where the data from the previous model is import. We can decide to change it if we want. So again, we run also this model and we get the final DNL results. So now I can go back. I don't know if you're writing something in the chat. I cannot properly see it when I'm sharing the screen. So if there's something going on, please let me know by saying something. So what we see now is that in this biomarkers page, we have the results of the first biomarker we evaluated. Now for the second one, let's say we already have the value. And so we input. And we can see it also appears here. So now we need one of the two to represent the whole inhalation route. So the system automatically decided for the one with the lowest DNL value, but we can decide for something else. It's up to us what we want to keep. So now that I selected one, I can go back and you can see it's here and it's derived by the model. In this case, instead, I can input data manually. And that's it. The system computed the probabilistic shape. So now that I input all my values, I can directly go to the result page and see what happens. So we have here the occupational in the product manufacturing, that is the only life cycle stage for the inhalation. This exposure is a deterministic value. We can see this, but we can also examine the different concentration in time. So this is not a probabilistic model as it is a time model, it's evaluating in time. We have the near field and far field and the selected exposure. At the same time, we can evaluate the hazard. So this is the hazard model we selected. More than the DNL, we can also evaluate the complete fitting of the model to our data points, the distribution of the benchmark dose, and the sources of uncertainty related to this. Finally, what we can do is evaluate the risk generated by exposure and hazard. So we get to this chart, where what we see is the distribution of the risk characterization ratio, which is basically exposure divided by hazard. So every time exposure is greater than hazard, we have a number that is greater than 1. So what we have here is that this line is establishing where the 1 is, and we can see that the complete curve is above 1. In fact, it's also easier to just look at the position of this line. So if the red line is in the red zone, it means we have risks. If it is in the yellow zone, it means we should try to reduce uncertainty and understand if we can move out of that. If it is in the green zone, we are quite sure there is no risk. Below here, we also have all the statistics related to the curve we are seeing. We can also compare directly the two values. So we can see that the exposure is far right from the hazard level from the DNL. And also here we can have a detail on the sources of uncertainty. And we can also do the same for the other route. So for the inadvertent oral, we have a probabilistic distribution of exposure. We have the probabilistic hazard, but without the model, so we don't have the other interfaces. And again, we have risk. In this case, you can see the red line is in the green part, meaning that all the risk is below 1, the risk characterization rate. And with this, I have finished, and I guess Francisco should take the lead now.
Thank you, Alex. Thank you for the presentation, this section. So before going to the questionnaire, I've seen 2 questions in the chat box. The first one by Sebastian, which is asking what happens when we cannot complete all the parameters, for example, on the exposure section. Yeah, I try to answer, but if you want to add something, Alex.
Oh, well, the system is functioning anyways, but you will get some gaps in your results table that we will see afterwards. I don't know, Francisco, what you want to say.
No, yeah, the thing that as much as you can fill in, the more accurate result that you will obtain, of course. That's
exactly.
Yeah.
And we included the models exactly because if you don't have the data in your hand, you might be able to generate the missing data.
Exactly.
And in the models, you also have a lot of default values. So again, if you really have no data, you can use default values, and obviously the uncertainty in the result will be high.
Mm-hmm. And we have another question by Rachel, and that you seem to be using the term biomarker in a non-standard way. Do you want Rachel to say something? Elisa just answered something. Yeah, a discussion is ongoing about the selection of this term in the DSS. So if you have any suggestion, it's also would be also very good. Rachel.
Hi, I think my question's been answered really. I'm just struggling to think of suggestions, but I was thinking, I just looked at it and thought chronic inhalation is not a biomarker. It's more of a sort of, it's a collection potentially of biomarkers, but I'm struggling to give you any suggestions, so I'll have another think. But
okay, thank you very much, Rachel. Okay, so we will go to the questionnaire regarding this section. So first, do you think that there is a need for controlling the potential exposure and hazard in your research or industrial or commercialization processes or facilities? Okay, it's pretty clear that yes. And then the second question for this section would be, do you consider the information on this module, the occupational risk assessment, useful? Okay, some of you think that this is very useful and others maybe don't know yet. That's okay. Okay, so that's the 2 questions from this section. So I will come back to Alex to explain the environmental part.
Okay, thank you, Francisco. I'm back. Let's share. Okay, so let's see what's in the environmental part. It's very similar to what we've already seen. So we start with the exposure. We see now that we have product manufacturing, soil, and water. The interface for the data input is the same. So what's interesting are the models. So again, in this case, the model is the same for all the compartments. So when I enter, in reality, we have two models. One is PFMA and the other one is the FATE model. So I want to apply both. So in this material transfer model, this is a bit complex. So this is the overview of the model. So you can take a look at it and check all the boxes that are. So you can see that the nanomaterials are moving from one box to the others according to some coefficients that you can specify. So the main inputs here are the total mass per year, the uncertainty, the number of simulations that obviously has decreased, and then the volumes. So the volumes we have input by default are the ones for Europe, but of course, if you want, you can change. And this means that if you input the production for your country and then the volumes for your country, then it will be country specific and no more Europe specific as it is now. And also down here, you have these tabs for the coefficients where you can go and change literally every coefficient in the tool. This is really something you should do if you know what you're doing, let's say. And you always, you should check the reference here if you want more details. So once I run this model, the model gets here, and you can see now, because this is a bit slower than the others, we can see in the jobs page how it is performing, and now it's finished. So I go back here and know that my facts have been derived, and so I can move to the next part, that is the environmental fate model. So you can see here we have different results. We can maybe change something. So again, you have to specify here something related to your exact content, and then we can run this model too. So this model has some problems and don't want to complete. I'm sorry. Sometimes it happens. Anyways, you run the model, you get the result of the environmental phase part. We will dig into this bug later on. So what you get in the end would be a probabilistic value here, like this. And the second part would run the same model. So it's exactly the same. So let's put also here some values. And so we now have evaluated our exposure. Let's move to the effect part. In this part, we can see we have a selection of two models. So the system is able to manage several models. So in the future, we might add also other models to the other parts. So as of now, we anyway consider a default model, the NSSWD model. So let's see what's in there. So I say that I don't have the data, I want to calculate them, and that I have a decent quantity of data points so that the model can run. So again, here we have a number of inputs we can change, and again, we can upload our Excel file. Okay. Now you can see all the data is being reported in the table here, and you can also go and change if you want. And you can obviously run this model. the model completed, and we got the probabilistic distribution instant result. So very similar to what we had beforehand. And the result is here. We can run the model again here, but it's basically always the same thing. So I will skip and generate. Again, we can go to the results page, and this time we move to the environmental setting. And you can see that now we have the environmental metrics here. Again, we have probabilistic exposure, we have the probabilistic effect with all the details of the SSWD, so the species sensitivity weighted distribution. The comparison between the p-nex and the uncertainty. And finally, also in this case, we have the same risk evaluation, so risk characterization ratio, and always if the red line is in the red part, we have some risks. Again, we can compare the two curves, and we see that the fact is always on the right side of the p-net, and that's why we have such risk. And also we have different sources of uncertainty again. And this concludes the environmental part.
Thanks, Alex. So I don't see, oh, yeah, there is one question by Rachel. Yeah, there is a need to put a lot of data in. Yeah, this is related to the previous question by Sebastian.
Yeah, I guess you can rely on the default values for many of these data. Maybe it's a good idea, like you're proposing, to highlight the most important ones. So this might be an improvement of the software, trying to highlight what you really should focus on, because some of those might really stay with the default values, but they are there because if you're a very specialized user, you can change it. But for some others, we should highlight your app.
Yeah, exactly. So, okay, we will launch 2 more questions for this environmental section. First, do you think that there is a need for controlling potential release to the environment in your research, industrial, or commercialization processes or facilities? Okay, most of you think that there is a need for controlling this release to the environment. And then, do you consider the information obtained in this module, the environmental risk assessment, useful? Do you think you will use it? Okay, again, as in the occupational section, most of you think that this is useful, and others don't know yet. Okay, so now we can move to the final section.
And there is another question, Francisco, about the quality of the input data and the metadata. So, yeah, well, the data that you input, if this data comes, it's related to your application. So you're responsible for the quality of your data in this case. We only provide default values that comes from literature. And metadata, I'm not sure what you mean in this context. I mean, if you want more definition of what the different inputs are, we can think about it. But because we are not, yeah, no, I know what metadata is, but I don't know in this case, because the data is coming from your environment of production. because we're not connecting to a database in this tool. The data is the one that you input for your specific case. So I don't know which kind of metadata we should add to this.
Martin, do you want to say something else regarding this topic?
No, basically this was actually my concern or my question. I mean, metadata would contribute to the quality assurance of what kind of input parameters, what kind of input data are used for getting a result. And the second question, which I was just typing in, is actually how is the documentation done? I mean, what happens to the data, to the results actually? What are the users are supposed to do with it, or what can they prove something with it? For example, that they have carefully investigated their processes or things like that. Going a little bit into the direction of liability of the entire thing.
Yeah, well, as far as the documentation of the results, what you can do now is you can export your images and some data, and then it's up to you creating a report. We are thinking about an automatic report creation, but it's still not yeah, about the well-characterized chemicals, equipment and consumables, we will see now for the risk controls, we already have such a library. And for the chemicals, we are, as I said in the beginning, we are about to add this characterization feature to the tool. And this will also allow us to connect to external databases of known chemicals. Yeah, you can share your projects with, and now we will see how it works. So yes, in theory, you can share the project with people you know. We still didn't allow to have public projects, but this is also something we were thinking about. So that would create communities like you're saying. So this might be also something interesting in the future.
Yeah, maybe we can continue with the demonstration, Alex, because maybe some of these questions could be answered with your
chat in the end.
Okay.
So let's go back to the tool. So up to now, we always worked in the. Oh, are you seeing my screen? No, so sorry. Okay, so up to now we've been working in the risk assessment part, but let's see what's in the risk control. So as I was saying in the beginning, the idea is to compare different assessment contexts. So that's why we have this comparison tab here. In this moment, the tab is saying we only have one assessment context, that is this drilling silver, and we only evaluated the product manufacturing life cycle stage in the occupational and environmental. So the system already integrated all the information about the risks and decided that the life cycle stage should be in an acceptable risk state. That's because at least one of the risks of the different parts, occupational and environmental, creates some risks. So I can check in more detail what's happening by going to the alerts page, where I can see that I have a problem in the occupational inhalation part, and then in both soil and water, as far as the environmental part. So I can do something to ameliorate the situation in the inhalation part by applying some risk management measures. So if I click here, what we have here is a list of risk control measures coming from the SL library from TNO, courtesy of TNO. So what we have here is this list. We have the name of the risk management measure. Upper and lower bounds of the average costs, its efficiency, and the average life duration. We also have these three circles here. The first one is telling me that it is applicable in one of my scenarios. And if I click, I can see that in fact is applicable in the product manufacturing inhalation part. I can also see that one of the scenarios where it is applicable, it's in an acceptable risk state. And in fact, we did know that this was in an acceptable risk. And then it's telling me that it's not applied yet. So I might just apply this technology and see if it modifies the results. But before doing this, it's a good idea to clone my scenario. So I clone my scenario to compare the two. And I say with risk management measures. So now the system reevaluated and copied everything from the first assessment context to this one. And you can see here that we've changed the assessment context. And now I'm happy to apply this technology. So now I applied it. So it appeared here, and this apply button it has appeared up here. That's because I might select more than one. So I might select another one and apply also that one. So once I'm done with the selection, I can apply the whole set of risk management measures. Let's apply this one. As you can see, the system recalculated and we managed to solve our problem. In fact, the state become green, and if we go back to the results page for the occupational inhalation setting, we can see that now it's in the right, in the green part, the red line. It was before and in the red part. So we can also go back to the comparison page and see that now we have two assessment contexts, one with and one without risk management measures. And we can see that if we have to choose between the two, it's likely we will go for the one with risk management measures, for sure. Finally, another interesting part is the one related to the sharing, like we were talking about beforehand. So if I go to the details of my project, you can see here I have a list of my colleagues or people that I know in the tool. So I can select this one and share with him. So now that I share, now here I am with the other user, this test user, and you can see he received a message here. If I open the message, it says that Alex Travel wants to share this project. I accept. And what I get is the project, exactly the same one. And more interestingly, if I enter a specific part of that, okay, you can see that if I change a value here, it's immediately reflected to the other user. So you can really work simultaneously on the same project and see the results of what the others are doing. And moreover, you can also express something about your project, saying so that you're always in line with your colleagues on what's happening. I guess that's all I wanted to show in this section. So let's go back to Francisco.
Thank you, Alex. Very interesting section. So I don't see any question for this section. So maybe we can go to the final part of the questionnaire. Let me share. So we have some question regarding this final part, and then we will have also a few questions about the whole DSS. So first, are you using any exposure prevention and or control measures in your processes or facilities? Okay, most of you are using. Do you think that the results of the risk assessment are presented clearly and are easy to understand? Okay. Mm-hmm. Do you like the possibility to simulate the use of different risk management measures? Okay, clearly yes. Would you follow the recommendations given by the decision support system based on the results obtained in the assessment? Okay, interesting result. And we go to the next one. Do you think that the access pages and the structure of the BIORIMA decision support system are clear? Okay, it seems that there is still some things to change on the structure. Does this decision support system cover all the aspects that you deem important for risk assessment and management? And maybe yes, no, or some of them. Okay. Okay, not all, but maybe some of them. So now, so if only some of them are, you think that are missing, which aspects or functionality do you think that is missing in this current version of the decision support system? Here again, you can write what you think in the box. Okay. Yeah, the data library. So we say previously. let's give some more time because this is very useful for us. Also, we will use your comments in the chat box. The comparability, yeah, of course. Okay, so basically the most important thing to add some kind of data library. Thank you. Also, this is related with some questions that we had before. Do you think that the input data requirements for the decision support system can be met easily through the literature and in-house data generation? In some cases. Mm-hmm. Okay. Mm-hmm. Do you think that the whole system, decision support system, could help you or your colleagues in your organization in your daily work? Most of you think that yes, some others don't know, or okay. What do you think that are the main obstacles for the use of this decision support system? Could be the complexity, the need of training, the lack of data, or the efforts to collect and generate data, or other. You can select more than one option here. Okay, in the most of the cases, the lack of data or the efforts to collect generate the data, and also the complexity. Mm-hmm. And let's move to the final question. Is there any other obstacle that you think that could make the use of the DSS difficult? Here again, there's a text answer, so you can write if you think the validation, management, reliability of the different tools, models, data. Okay, it seems, yeah, the validation, it could be one of the most important points to check here. Okay, so that's everything from my side. Okay. So I will stop sharing. So that's everything for today's webinar. So maybe we can have some minutes for open discussion, or if you have some some questions. Let me check the chat box. Martin Himley said that we need to test by himself, of course. Mm-hmm. Yeah, of course we are still working on the DSS. We are making this webinar to check with external people, just exactly what we have done, and to check if we need to add some specific other sections or extra help in parts. Okay, so more comments are coming. Is there an open demo version to explore? Yes, Alex answered. It's in sans.gd. You could go there and register and just try the DSS. And actually, you can try it, and if you have some questions, you can just write either me or Alex an email, and any kind of feedback from your side would be very, very valuable. We might consider, yeah, Martin, that would be also a very good point to test with some students. So any other comment or question? Alex, do you want to add something?
Oh, in reality, no. I would be
Okay.
like to want to test it with students, because then it will give me also an idea of the bugs and improvements it could apply. So that
Yeah. Okay, so that's everything from our side. Thank you everyone for your feedback and for your attendance. So have a very nice day and a nice weekend. Thank you very much.
Thank you. Bye-bye, everyone.
Thank you. Have a nice day.
Bye.
Thank you. Bye.
Bye.
Thanks. Bye.
Thank you very much. Have a nice day.